Hello friends, welcome to Shiksharthi. In this session, we'll be talking about how a line can make an angle, an acute angle, or an obtuse angle, or a reflex angle with the positive direction of the x-axis or the negative direction of the x-axis. While doing so, you will see that this discussion can be closely associated both with coordinate geometry and trigonometry as well. So let's start. Now, there are two Cartesian planes that I have drawn. Now, when I use the word Cartesian, I am basically referring to the real XY plane. So, starting off with the black colored Cartesian plane, and we know that this is the x-axis. So this is the positive direction of x-axis, and on the other hand we have the negative direction of x-axis. This is the positive direction of y-axis, and this is the negative direction of y-axis. We know this. Now when we draw a line, even before we draw a line, let us talk about the x-axis. And when we are moving from left to the right, that means we are basically talking about the anti-clockwise direction, or we are talking about the clockwise direction. So let me start off this discussion with the anti-clockwise one first, and then we will come down to the clockwise direction as well. So I am doing the same. We are representing the positive and the negative direction of both the axes. Now let us say that I start from this line on which I am representing a point, and then I start moving on. Now this is the way wherein the angle increases. Now the angle is moving on to the third quadrant, and as I am drawing, it is still in the third quadrant, and now it moves to the fourth quadrant. And just for the sake of better understanding, I am just drawing it once again so that finally you are able to understand, and let us say it ends here. So we started off with the first quadrant. This is the first quadrant, this is the second quadrant, this is the third quadrant, this is the fourth quadrant, and this is how this represents the direction in which the angle, the said line that I would have drawn, the line that I can draw here is a line which can pass through the point of intersection of both the axes, or there is a line that I can draw which does not pass through the point of intersection of both the axes, right? Now in the other case, let me do the same. The only thing that I need to do here is I'll start, let us say I assume a point on the x-axis from which I start, and when I say I am moving in the clockwise direction, so let me start. We start off with the fourth quadrant first. This is the fourth quadrant. We now move to the third quadrant. Now the line, let's say, goes to the second quadrant, and we are coming back to the first quadrant. And again it goes to the fourth quadrant, then the third quadrant, then the second quadrant, and finally it comes to the first quadrant. The arrow symbolizes not only the direction but the quadrant in which we are moving. For example, this arrow shows that we are in the fourth quadrant. This arrow shows that the angle is in between, let's say in the third quadrant. This arrow shows that the angle is there in the second quadrant, and this arrow shows that the angle is there in the first quadrant. Just for the sake of writing, we can write down the quadrants here as well. So first quadrant, second quadrant, this becomes the third quadrant, and this becomes the fourth quadrant. And the same we can do here. So this is my first quadrant, this is the second quadrant on the Cartesian plane, this is the third quadrant on the Cartesian plane, and this is the fourth quadrant in the Cartesian plane. So till now we were talking about a line making an angle with the positive direction of x-axis. This can be done in two ways. The first way is the anti-clockwise movement of the line. For example, I could have taken a line like this, and then I keep on increasing the angle such that it keeps on moving from the first quadrant, passes through the second, then third, and then finally lands in the fourth quadrant. Or I make a case wherein there is a line which there is an angle which a line makes with the positive direction of x-axis, but in that case the direction is the clockwise motion. How is this discussion going to help you in trigonometry? This will help you to ascertain the trigonometric ratios, and not only the quantity of the trigonometric ratios, but you will also come to know the polarity of the trigonometric ratios in the various quadrants, which we will be talking about in the other videos. Right? Okay. Now, once we have done this, let's take this to its logical completion. So let's say this is 0 degrees. This is 90 degrees. I'll put it as plus 90 degrees. This becomes plus 180 degrees. Let's say this is plus 270 degrees. Further, when I keep on adding 90 here, so let me keep on adding 90 here. So instead of simply calling it as a 0 degree, we could have said that this is 0 degree. The next value that I'll get here is a 360 degree. The next value that you will get here is a 720 degree, etc. Similarly, the next value that you could have got here would be you add another 360 degrees to it, and that is how you take the discussion to the next level. So now going forth, after all these various observations, let us see how is this discussion going to help you in trigonometry, wherein the coordinate geometry aspect we have already talked about. Right? Now let us see how is this discussion going to help us as far as trigonometry is concerned. So for this, I am going to use Euclid's division, which is nothing but dividend is equal to divisor into quotient plus the remainder. So you would see now here theta is equal to 360 degrees into capital Q plus the remainder is the value of theta, which is the dividend in this case. 360 degrees is the divisor. Why have we taken the divisor as 360 degrees? Because we see that the value, for example, after 0 degrees, the value repeats itself after 360 degrees. So for example, the next value after 90 degrees would be 360 added to this, which will be 450 degrees, and so on. So the value of Q will tell in which quadrant is that particular value of theta going to lie, and the remainder will also decide the quadrant. For example, if there are 4 cases that we have made here, the first case is if the remainder lies between a 0 degree and a 90 degree, in that case the value of theta lies in the first quadrant. If the remainder value lies between 90 degrees and 180 degrees, in that case the value of theta lies in the second quadrant. If the remainder lies between 180 degrees to 270 degrees, in that case the value of theta lies in the third quadrant. And thereafter the final case that will be given rise to is when the remainder value lies between a 270 degrees and a 360 degrees, in which case the value of theta lies in the fourth quadrant. How are we going to make use of this? So let us say that if somebody says that theta is equal to 910 degrees. So now a learner will be interested in knowing that in which quadrant is the value of 910 degrees going to lie. For this, now it becomes very easy with the help of Euclid's division method, in which you would say that divided by 360 degrees, so 360 degrees into 2 makes it 720 degrees plus 190 degrees, which makes the value lie in the third quadrant, because if the remainder lies between a 180 degrees to a 270 degrees, in that case the value of theta lies in the third quadrant. Analogously, if somebody would have given me the value of theta as minus 910 degrees, in that case we would have said what? We would have said that this is nothing but minus 360 degrees. into 2, right, into 2, and then we would have added another minus 190 degrees to it. Now when I say adding minus 190 degrees to it, what do I mean to say? For that, let me refer to the clockwise direction, in which, let us say, the x-axis, the positive direction of x-axis from where we start is 0 degrees. Now, as we are moving from the fourth quadrant to the third quadrant, in between I'll get minus y, which is minus 90 degrees. When we move forward, we will say this is minus 180 degrees. When we still move forward, which we will say this is minus 270 degrees. When we still move forward, we would say that nothing, the next one here is minus 360 degrees, and so on. So now as you keep on moving in the clockwise direction, the value that comes after minus 90 degrees is minus 450 degrees. The next value which comes after minus 180 degrees would be, you add another 360 to it, which is minus 540 degrees, and so on. So now the value of Q that we get from here would signify how many rounds you would have taken. For example, for 910 degrees, how many full 360 degree rounds you would take? You would take 2 full rounds. Analogously, for 910 degrees also, you would be required to take 2 full rounds, and then one fourth quadrant and the next. So for example, after minus 540 degrees, what is the next value that you're going to get here? The next value which you are going to get here is minus 900. And then for minus 910 degrees, you will have to act accordingly. Right? All you need to understand here is when you're moving from the fourth quadrant to the third quadrant, and when we say fourth quadrant, so let us say we started off from a minus 360 degrees. In that case, the limiting value here would be minus 540 degrees, etc. So that will give you a fair enough idea of in which quadrant is that value going to lie. I hope you have understood this, and you'll have to, and it becomes easier for you to take this to the next level. So the next level is take some values of thetas and find out in which quadrant is that value going to lie, because the next learning from this stage would be what is the trigonometric ratio of that theta that you would have taken, and in which quadrant is it lying, and the next stage would be what is the value that you can give to that trigonometric ratio of the value of theta that you would have taken.